in this warm-up, it says calculator active, which when you get to the AP test, you're going to have part of the test that is calculator and that is no calculator. If you see a problem like this, you don't need to show any work. All right, you answer the question and you're done. And actually, you don't even need a calculator to answer the multiple choice part, but the extra piece that I put in, this is where you would use your calculator. Well, let's take a look at what we have. So we have the function d. What does d stand for? It's defined by the model above that gives us the depth in feet of water at t hours after midnight in a certain harbor. Which of the following presents the method for finding the instantaneous rate of change? So right there, when you see instantaneous rate of change, we're thinking it's the derivative. So which one of these identifies the derivative? And you can kind of look very carefully. I'm actually more interested in the wrong answers than I am the right answer. But let's take a look at each option. What does option A tell us? Well, it gives us two times. It gives us times 0 and times 6, and it gives us the outputs. This is the quotient, which is just our average rate of change, right? Or sometimes we call it AROC, average rate of change. That's just if I give you 2 points, we found the slope of the secant line by using the regular slope formula. Now, we will say right away the derivative is d prime at 6, right? This is our answer. This is the derivative. But what does the second one? This is our second derivative. Now, I should mention here, this is the instantaneous rate of change. Or I like to abbreviate that as IROC. But what does d double prime actually mean? Well, this is the rate of change of rate of change. It's like the double rate. It's the second derivative. So it's the slope of the slope, or the rate of change. And I know it's really weird to say that. That's why we don't really call it that too often. And then what is this? Just regular d of 6. That's just plugging 6 into the original function. That's the depth. Or some people like to think of it as like your position, right? And if you really want to, this doesn't deal with motion left to right or up and down, but you could think of, here's my position, here's my velocity, and here's my acceleration. And then this is just the average rate of change. So understanding this question is very interesting. But the reason why I wanted to do this problem is so you guys could use your calculator and find what is d prime at 6. So hopefully you grabbed your calculator already. And you went, now this is something that I hope everybody knows. We did this a couple of times in warm-ups. So if you were late to class, you may have missed it, but I expect everybody to know how to do a derivative in their calculator. So I'm going to go to math. And actually, because there's a cosine, I do want to make sure that my mode is in radian mode. So in that case, if you don't have it in radians mode, you're going to hit mode and then go down to the third option and hit enter on radians. And that'll be, you only have to change it once if you're using your calculator at home. Okay, so now there's two options. The fastest way, because I don't really need to see a graph, is go math and option 8. That was n derivative. Now if you have the TI-84 at home, it looks like this. If you don't, I would use the one on your Chromebook. And we're just going to do dx of the function. And then I like the fraction piece here. So I'm going to go alpha y equals, and that gets me that fraction piece. And then I'll put pi, and the t can go right next to the pi in the numerator, or you could put it to the side, and we have to use x instead of t. But all I did was type the function in, and actually I should probably end the parentheses here because it gave me two sets of parentheses. And the last part then is, where do we want the value? I want the derivative of this function at 6. Hit enter, and you get 0. And I believe that's kind of a rounded answer. I actually think if we did it by hand, we would get even a slightly more accurate answer. But there we go. We know the rate of change. Now, one of the questions that you're going to see on the test on Monday, Tuesday is find the derivative and then what are the units? And we have to compare, well, what did we compare? We compared the outputs, which was feet, to the inputs, which is hours. And your units here would be in feet per hour, because we just found a rate, right? Compare the y's over the x's. All right, if you are struggling with this or you don't know how to use your calculator, that's a sign that you need to talk to me and figure out how to use your calculator and stop in and get some help. Okay, really quick, couple of things. What is left of this trimester? So, where are we at? Well, today is Thursday the 19th, so we're going to review for the test. This is our last test. And then you guys, being second hour, are going to have it on Tuesday, Tuesday the 24th. So what is there left to do? You could try to improve your grade by doing test corrections. If you do, email them to me. And remember, you can get up to 75% back if your test corrections are worked out nicely. And you just do that on a separate sheet of paper. All old tests should be visible still. Complete any missing homework or quizzes and submit those to Schoology. And then complete any missing tests if you have them. So get that stuff done. I want to have grades completely finalized by Sunday, meaning, or I should say Monday. So you get all your missing work in by Sunday, the 22nd, and then you take the test and you're good and you can enjoy Thanksgiving break. Okay, one of the things that I just need to address here quick, because this is becoming more of a little issue here. Wednesdays, you are expected to engage in my class on Wednesday. And what should you do? Well, if you click on week 12, there's an agenda. Go to Wednesday. We have the same agenda, and there are two expectations. Watch a video and take the 4.1 quiz. 15 students out of 32 did not even take the quiz. Didn't even open it. And my guess is how many even watched the video. Now, these are the notes that go along with the video. I'm going to just show you something really quick. There were two problems that I went over, and I just kind of explained the expectations for the day. One of them was an AP style question that dealt with L'Hopital's rule. So I reviewed L'Hopital's rule, which helped for the quiz. And then I did a problem that was almost not identical, but very, very similar to one that you saw on the quiz. So if you watched the video, this helped you with the quiz that you were just about to take. All right, so that was the expectations here. The other thing that I want to note is if you miss a class, like let's say you missed Monday, right? We have everything here in the Monday folder, blank notes, filled in notes, where to turn the homework, and then the video. Now, if you were even 5 minutes late to class, you may have missed the warm-up part where we talked about doing derivatives in your calculator. So those are things that I expect you guys to go back and look at. And if you look at Thursday here, here's our agenda. So this is today. Here's the review worksheet. and then here's where you're going to submit the review worksheet. I take that back. This one is where you submit it. This is the actual worksheet itself, and there are answers attached to that. So I'll just show you that quick since it's here. And don't get scared by the amount of problems on this. I'm not going to have you do all of them, but if you scroll to the very end, the worked out solutions for every problem are here. And we're doing that because if you get stuck, you should kind of quickly check and see how do you start a problem and then see if you can finish it on your own. So let's talk about what we're doing today. Very first thing is, what about this test on next week, Tuesday? All right, so the test is going to be 50 points summative, plus you will get 10 points for turning in your written work, and those 10 points are going to be summative as well. So you can kind of think of this as like a 60-point test, but really it's 50 points, and you get 10 free points for showing your work neatly and clearly for every problem. All right, so what is going to be on the test? Well, we didn't cover this directly as one specific unit, but we took 3 separate days as warm-ups. And basically 4.1 was, how do you use your calculator to find derivatives? That's what we did in the warm-up today. So here's the context of the problem, use it to find the derivative. You don't have to show any work, you just plug it into your calculator and you're good to go. Then we did 4.2, which was, this was 2 Wednesdays ago, local linearity, where you had to write the equation of a tangent line and then use that to approximate a value. So there's going to be one question on that. And the big part from this unit was L'Hopital's rule. And you must show proper notation. I want to show you something just quick with the notes that I had from Wednesday. What I'm noticing on students' work when you're turning it in is a lot of students are forgetting a couple of things. So let me just quick show a problem here. So if you look at this problem, I had to just find the limit when x went to 0. So what did I do? I took the numerator as a separate limit right here. Notice all I did was write the limit as x goes to 0 of f of x plus 1. And then I plugged in 0 and evaluated it. Okay? You have to show this step. You have to show that the original numerator, you can't plug in 0 right away. If you skip this first part right here, you're not going to get full credit. Okay? Same thing with the denominator. You got to show that the denominator, the limit of the denominator is x goes to 0, and then evaluate that. And then we're comparing it as 0 over 0. Now notice, I didn't say that the original limit was equal to 0 over 0. If you do, that's incorrect, because we're just checking that the indeterminate form exists, and then this blue work gives me the reason, or is the reason, that I get to do L'Hopital's rule. So then I actually show the derivative of the top over the derivative of the bottom, and the limit as x goes to 0, and then I can plug in 0 and evaluate to get my answer. So pay very special attention to the work that we're showing here, because to get full credit, I need to see everything that's written here. Okay, so what else could be on the test? And here's the part where you might be a little nervous. This is going to be a cumulative test, meaning we are going to have pieces from all units. The nice thing about this is we've done a lot of this spiraled throughout the whole curriculum this trimester. So hopefully you can feel pretty confident in this list, but I'm just going to go through a couple of things really quickly. What else have we learned? Limits, right? Can you evaluate a limit from a graph, a table, or algebra? And the nice thing is L'Hopital's rule ties into this evaluating limits piece. So we've kind of been reviewing this all along. Another reminder is when we look for limits, if I want to figure out if a horizontal asymptote exists, that means the limit as x goes to either positive or negative infinity of a function is equal to a number, which basically says as I go to the far left or right, if I'm equal to a number, that means my graph is going to approach that number. So therefore, there's a horizontal asymptote. Okay? Well, what does a vertical asymptote look like? Vertical asymptote is the undefined line straight up and down. So that means that if I take the limit as x approaches a number of some function, if that answer is equal to positive infinity, so like let's say I go to 3, as x goes to 3, if my function goes to positive infinity or even negative infinity, that means there's going to exist a vertical asymptote. Okay? Understand what continuity means. When we say continuity, I think of it graphically, but does the limit of the left equal the limit to the right? And does the point exist? If that is true, then the function is continuous. If it's not continuous, then we had types of discontinuity, which were, removable. Then we had the jump discontinuity. We had the vertical tangents. And then we had the oscillating one that goes like this, but we didn't really focus on that. So know the types of discontinuity. The intermediate value theorem, right? This one you should have clearly identified in your notes. I'm not going to write it out, but I'm going to just talk about it. It basically said if a function is continuous, all right, the conditions, this is if continuous on the closed interval from A to B, right? So if it's continuous from A to B, then that means that every single value between the output of A and the output of B has to be met. And that was the example of saying, like, if you were 5 foot at the age of 12 and now you're 6 foot at the age of 18, between 5 foot and 6 foot, you had to hit every height in between there because you're growing on a continuous level through a closed interval. All right. Know the difference between average rate of change, that is just slope. When we think of average rate of change, that's just your change in y's over change in x's. But the big thing is, for average rate, you need 2 points, right? Well, instantaneous rate of change is just the derivative. It's the derivative at a single point. So we have 2 ways of calculating rates of change. Average rate of change is just the slope of the secant line. Instantaneous rate of change is the slope of the tangent line. Right? And then we have the limit definition of the derivative. Now, we're not going to have you, I'll just let you in on a little secret, we're not going to have you use the limit definition of the derivative. If you remember all that long algebra stuff, we don't need to do that stuff anymore. But we could ask you a question that involves this. So if you remember, should be a plus. This is one of the derivative limits, the limit of the derivative definitions. It's the change in the outputs when we have a spot at x and a spot just h units away from x. And then it's the limit as x goes to 0. So you really don't have to use this, but you have to be able to identify that certain functions exist in that. All right, differentiability. If we say that a function is differentiable, it implies it is already continuous. So if you know it's differentiable, then it's already continuous, and that works out. But what is differentiable? Well, differentiable is, does the derivative on the left equal the derivative on the right? And the way we can kind of state that is, I'm just going to pick a random letter, A. So does the derivative of the function on the left equal the derivative of the function on the right? Okay, or another way to say it, does the slope on the left equal the slope on the right? If I go back to this function right here, this really rough sketch, we knew it was continuous, but this function is not differentiable because the slope to the left is positive and the slope on the right is negative. The other reason is it's a corner, right? So we had spots like corner, cusps, and vertical tangents. Those are spots where it's non-differentiable. Okay, so basically almost all of this was Unit 1 and part of Unit 2. That was the early on stuff this year. And a lot of it is kind of definitions and theories. Then we got into the rules. And the derivative rules are huge, right? We've been using that ever since we learned it. So like the power rule, that should be very routine right now. The product rule should be routine, quotient rule should be routine, and the chain rule, you should think every derivative that I'm going to take, there will probably be a chain rule in there, right? So I'm hoping you're very familiar with the chain rule. And then just remember, what about the derivatives of all the functions? You have your list of like 20 some derivatives, and that includes like the derivative of sine inverse and tangent inverse, or the derivative of ln, or e to the x. The one that is probably most forgotten, what if I gave you this problem right here? Actually, let's do it. Let's do a chain rule one. What if I told you right now, maybe in your head, take the derivative of y equals 7 to the power of x squared? What is the derivative of that? All right. So hopefully that should be a 30-second problem. What am I looking at? If it was just 7 to the x, the derivative of just 7 to the x is itself, but in this case it's an x squared, times the natural log of 7, right? But we actually have the chain rule we have to be worried about. So now I have to take the derivative of the inside, which is 2x. And there isn't a great way to rewrite this. So I would just say, let's stop here. But this is a perfect example of, do you know the derivative of just 7 to the x? And then do you understand that there's an exponent that isn't just x, it's x squared, so the chain rule has to be applied. All right, implicit differentiation. This is dy dx, right? So if I gave you an example, let's say I had y squared plus 3xy equals x. Well, you have to take the derivative of each side. And when you do that, I think we're almost done here. When you do that, it's pretty quick. It's your old derivative rules. So I got to take the derivative of each piece, but right here, I have to apply the product rule. So I'm going to just do this really quick. The derivative of y squared is 2y, but because we're taking the derivative of y, it's dy dx. And then I've got the product rule. If you want, you can come over here and you could say, let u equal 3x, let v equal y, and then you could do the product rule doing all that work. But we kind of said, I hope we're past this part in green. I hope we can just write that out from knowing it. But what is it? It's 3 dx dx, but we know the dx reduce out, so it's really 3 times y plus the first times the derivative of the second, which is 3x dy dx. And then that has to equal the derivative of x, which is dx are just 1. So that's just taking the derivative of each piece, and now I have to move everything that doesn't have a dy dx over to the other side. And I'm going to skip one extra step here. But this one stays. This 3y in green is going to subtract over. And then notice what was left over was a 2y and a 3x, and they both had dy dx, so I just factored that out right away. And then my last step is to divide both sides by 2y plus 3. Now I should check if everything had a common, let's say that each one of these numbers was divisible by 3, then I would divide out a 3 from each one. So if they all have a common factor, you do want to reduce that further. All right? Okay, we're almost done. Higher order derivatives. That could be something like, all right, find y prime, find y double prime, find the third derivative, find the fourth. So it's just saying you can keep taking the derivative over and over again. And then remember position. Okay, position was just our normal function. Usually we use s of t. Well, then in that case, the derivative of s of t is velocity. And how do we get speed? This is the one that we don't do a ton with, but it comes up. Speed is just the absolute value of velocity. So all I have to do is if I know the velocity, I just turn it positive, and that's the speed. And then the acceleration is the derivative of velocity. So maybe I don't like those arrows there. But that's our link. And some people even want to do this, which is kind of nice because that's how it's related. If I take the derivative of the position, that's velocity. If I take the second derivative of the position, it's acceleration. Or if I take the derivative of velocity, I get acceleration. All right, that is most of what we covered. And those are the things that you could be tested on. It's a lot. Now, I don't want to freak you guys out, but I also want you to understand that the AP test is going to expect that you remember everything that you've ever been learned in calculus or you've ever been taught. So you have to be prepared. And if we don't keep testing these skills throughout, you're going to forget them and lose them. So here's what we got today. And I want to make sure everyone is very clear on this. That review worksheet, I'm going to have you do these problems here just on a separate sheet of paper, and then you're going to just submit an image of that. Okay, now, these problems are just kind of bare minimum to get you to review some of the concepts that we've talked about. If you really want to be well prepared for the AP test, you should do as many of these problems on this worksheet as you can. All right, so let me just show you this quick. There are, and I understand this is a lot, there are 32 problems, right? Some of them are really quick, some of them are not. Some take a while, like some are just multiple parts. And to be honest, these are all really good problems that you should try. So with that being said, here's kind of our agenda for today. Notice it says in-class review day, so we just kind of talked about it. Then you're going to spend the rest of the time in class working on this review worksheet, doing the required problems, or doing all the problems to better prepare you for the AP test and this test next week. When you're done, you can click on here to turn in the review worksheet. All you do is take a picture of it and submit it. And then here, the bottom link is where you find the review worksheet. So that's in the Thursday folder, bottom link. You can open it up and start working. So I'm gonna double check attendance right now just to make sure I didn't miss anybody. And then after I get done, you are free to do one of two things: work on the review, or 15 of you or 10 of you for sure have to go through and finish that quiz from Wednesday. So some of us got into a little bit of a hole with not not doing any work on Wednesday. So you got to make sure that you get that done. But that's all I officially have. If you feel comfortable, you no longer need to be on Zoom. I checked attendance. We're all good. You can spend the rest of the time working. Oh, hold on one second. Um, sorry, I just remembered this. What I'm going to do, and I will let you know, or you let me know, I'm going to actually release the test on Saturday, and I'll send you an email. So if you want to take the test on Saturday or Sunday next week, when you know, or this coming Saturday, Sunday, when you know you have an hour and 15 minutes blocked off without any distractions, if you're ready, you could take the test this weekend instead of taking it on Tuesday in class. If that's the case, then you would have to show up for class on Tuesday to get attendance, and then you're good, and you're kind of ending at least the math class early if you take the test this weekend. I have to fine tune it a little bit so it will not be available until Saturday. And I'll email you that option if you would like to take advantage of it. All right, that's all I have. The rest of the time is yours. I'll be on Zoom if you have any questions, or I'll be at my office hours today from 1 to 2 o'clock.